Assalamualaikum and good day. Today I would like to introduce our tutorial in the week's 11th on the friction. So we have several questions here in the tutorial in the friction topic friction. So how to solve the problem on friction? I would like to go first to give example to how to answer tutorial in the friction. So let's check question number 1 first. The mine car and its content have a total mass of 6 megagram and a center of gravity at G. So please refer to figure. If the coefficient of static friction between the wheels and the track is mu s equal to 0.4 when the wheels are locked, find the normal force acting on the front wheels at the B and rear wheels at the A when the brakes at both A and B are locked. Does the car move? So the question refer to the wheel on the figure. Okay, so we can see here the trolley have the certain mass and the central gravity here, and the pull by 10 kilonewton to the left side. So this dimension already mentioned in the figure. So the question is if the wheel brake have the mu static is 0.4. So before we answer, as usual, we start with the FBD. Anything to be starting with the FBD, free body diagram. So we can redraw here with the mass here, and then we have a wheel here. Yes, so be all dimension should be referred to the figure. Yeah. Okay, we have here the force acting 10 kilonewton and also gravity, central gravity here. Yes. So we measure down here, and here is 0.9 meter. Okay. After that, we can measure the force acting here in the wheel B as normal B, and also force acting as friction FB, and also in the point A we have FA and also normal F in A. So after that we can finish it by approaching moment. Okay, as we know, moment in the counterclockwise consider positive. Okay, then we try to sum Okay, so we start from the point B, also 0. Okay, then what we do, we sum moment a 0 at the point B. So anything that can create force can create the moment, we can sum. So firstly, we go from the normal A here, normal A, and then times by the distance 0.6 times to 0.9 is equal to 1.5. Okay, 1.5 meter. The unit is meter. And then in the direction is equal to counterclockwise. So that's why we have in the positive direction, and also another positive direction in the similar direction counterclockwise. Okay, we can check here. This one 10, yeah, 10 times 2 here 0.9. Okay, 10 times 2 0.9 plus the radius of sorry, the yes, in meter. Okay, and then what else? We can check here the direction other moment in the what else? Maybe we can check in the direction opposite or counterclockwise, clockwise, clockwise. Uh, by week 6 mega is mean 0 and 2 equal to kilometer. Then in the direction of clockwise, so we can write here. And to a distance is 0.6. Then equal to 0. Okay, from this equation, we can carry out the an A, yeah, an A from our calculation, we got 16 point kilometer. Okay. Or we can round it into the 0.5 kilonewton. Okay, now the unknown parameter of Na already solved. Now we try to solve another unknown in this problem. So another one we have NB for the unknown, and also we already only one here, still unknown. So we can solve by using summary in the direction of y. So we sum of y equal to 0. So we try to solve anything in direction of y. We have here NB, NA, also we have N, also weak. Okay, let's go to solve it. First, we have the NB in the positive direction, is mean to the upward, and also we have the NA here, also in the same direction, will be positive. And then what else? Yes, we have a weak here. What else? Finish, yeah? Okay. Sorry. Now we try to input in the equation for all known parameter. For NB, still unknown, but NA already solved. And also in weak, yeah, already known. Okay, now we can solve for NB. So because already known in the NA, now we can sum as 42 in 3 kilonewton. So back to the question. If the wheel in the lock system equal to 0.4, so should be, if we lock in wheel B, should be calculated by times to 0.4. And also if we lock all wheel A and B, should be both of the wheels should be times to 0.4. So let's do it. Okay, for first question, if will be locked. Okay, now calculate for force that occur in the will be will A. The question is at B and A brake and box. Yeah. Okay. The first with the FA. Okay. Untuk mu S tentu and A. B tentu S to and B. Okay. Let's do it. For A first, 0. For control NA, there's NA, 16 kilonewton. Then also one. If you lock in the will be 2 kilonewton. Okay, can get for A first 6 6 kilonewton. Then for the B, 16 9 2 4 kilonewton. So okay, now we compare for the wheel A first. So we pull, yeah, the trolley by 10 kilonewton. So if you compare to the force to pull out, so B is less than 10 kilonewton. How about the B? Yeah, B is higher below 10 kilonewton. So how about if we lock both the wheel for A and B? So B, FA plus FB. Oh, 1, 2, equal to 23 and 9 kilonewton. So its mean is higher kilonewton. Okay. Okay, for the first case, if we lock wheel A, this mean force A cannot resistance into the force of pull out. So it means the trolley will moving. If we lock for the wheel B, it means the trolley cannot moving. How about the both of the wheel lock? So more higher of force friction is mean cannot move to direction to the left of our side. Yeah? Okay, I hope this answer question can answer all the question in the number one. Question number one. I hope you can understand about how the procedure and the step to the answer from the initial until to the finish. Okay. If you have any question about number one, we can discuss later on. Yeah. Now we go to answering in question number two. Okay. Okay, as mentioned in the tutorial, the question number 2, if the horizontal force P, P is here, please refer to the figure, equal to 80 Newton. So we'll push to the box with a certain angle, theta, equal to 20 degrees. Okay, determine the normal and frictional force acting on a 300 Newton crane. If we consider mu static equal to 0.3 and mu kinetic equal to 0.2. Okay, as usual, before we complete the calculation, we should create the FBD first. Okay, we refer into the box to the create BD. Okay, here. So we have P here in the X direction. 80 Newton. Then at the same time, we have mass here, and also we have angle theta. So here we have the W in cosinus, in sinus. This one is in cosinus. So you can rewrite here as N, and C equal to W sine, cos theta will and in the direction of X. We can say an X or something, another name, equal to W sinus theta. Okay, so like this. Okay, now after finish the FBD, we can complete. Okay, we have also this one, theta. The question. So we go first how to answer in the certain angle here, positive, and then we call this one is in X. So because this one actually the arrow is not exactly in the 90 degree, but have the angle to mention the condition of the box condition. So we have here active, in the active, in the X direction, Newton, down to cos theta, because it's considered positive to the right side, and also negative. We have here 300. Yes, Newton down to sinus theta, and in the positive direction, we have the FC. FC is mean here to resist the box from to down to the ground. Yeah, so we have a FC here. Then we can finish it by carry out the FC equal to 27.43 meter. Then we have another unknown, yeah, about uh, the NC, yeah, the NC here. In the Y, a certain angle. So how much is it? Yeah, the NC. Actually, the NC, this one is not equal to the this one is our NC, correct? But this one is my NC. We call another name. We have the here. Maybe we can rename here the normal in the direction of the box. Yeah? Maybe we call N box. Yeah? Normal to push on. So the BD is not complete yet. So the force. Yeah? So this is the box, yeah? From the field. Okay, we have the box here, the positive way, and then we have 300 Newton cos theta here, and C, and then negative to 80, yeah, in the sine theta equal to 0. So in box, we can solve by 309 point 26. Okay. Okay, back to the question. Determine the normal and friction. The normal already here and friction. Okay, is already answered here. Okay, if FC equal to mu static time to normal box, yeah? So you can recalculate here 0.9 see equal to 2.8 Newton. Okay, if we compare to the FC, to the friction force is higher. Yes, it's higher compared to the force. Okay, it means the force that acting to resist the force is higher. So it means the box cannot move. Yeah? Cannot move. So static. Okay. Okay, that's all for tutorial question number 1 and number 2. So you can finish all questions that I give in the ULearn. Please submit in 1 week. If you have uh, missing or the question, please discuss with me, and see you to next topic. We can meet you again in the next topic. Okay. Assalamualaikum and good day.